Welcome to Radar, Safran's podcast that takes you behind the scenes of aerospace and defense. I'm Kayla Rourke, and in each episode, I meet with guests to explore an exciting topic that shapes our industry.
Ladies and gentlemen, this is your captain, and I'd like to welcome you aboard Flight Safran Radar.
Hello, everyone, and welcome to Radar. Today's episode is a little bit unusual because we're not welcoming you to our studio, but to Molsheim, near Strasbourg. We're here at the Safran Landing Systems, the world leader in landing and braking systems, on a site where more than 1,000 employees work side by side every day. And we've come here for one specific reason: to discover the ExcelFAB, a state-of-the-art building where critical aluminum parts for landing systems are machined, and which proves that at Safran, the factory of tomorrow is already underway. And you're in luck, because today we have our own private guide. Hello, Julien Mille.
Hello.
You are Project and Investment Manager at Safran Landing Systems. So, Julien, you know this building inside and out. You're almost at home here, in fact, completely at home, because you've been here since the very beginning of its design. You were even one of the people who helped design it, which we'll come back to later. But for now, should we begin our tour?
Let's go.
So, Julien, we're here in the ExcelFAB, in the operations area. Why are we starting our tour here?
Well, because this is where everything happens, and it's around this area that everything was designed. The production line consists of an intelligent, automated supervisory system, and here we can clearly see the 3 loading stations. The first one handles the incoming raw material and the outgoing machine part, and next to it we can see 2 others that supply the machining centers. Here, time is gained through a compact layout around the operation area, optimized and limited movement, and the availability of information as well, which we'll look at it in a little more detail later.
Yes, and we're definitely going to continue this tour. But before we do, Julien, could you tell us a little bit more about how this project came about?
First of all, the context. We had to cope with a production ramp-up, particularly to respond reliably to the needs of Airbus and Boeing for the A320, A350, A330 families, and the Boeing 787. We had to double our machining capacity and produce 10,000 parts a year, and that required expanding the facility and increasing the floor space. More than an infrastructure project, it had a dual requirement. It was a project that aimed to be innovative, while also delivering advanced quality control. So we chose useful digital technology. We didn't go for the gimmicky digital technology. We had our performance and modernization objectives, and we selected the technologies that were relevant in helping us achieve them.
You were talking about useful digital technology. And in fact, when we talk about this ExcelFAB, we talk about an Industry 4.0 factory. It sounds a little bit like the factory of the future when you put it that way. And yet it already exists today. So what actually makes it so different from others, especially for our listeners who may or may not be familiar with this kind of facility?
Industry 4.0 fundamentally changes how we use data. It gives us better control over product quality by making better use of the conditions that ensure it. Take temperature, for example. The workshop temperature is controlled, of course, it's a modern facility. But we've also added automatic measurements before every precision machining operation. They compensate in real time for thermal expansion, making our production less sensitive to temperature changes. The same applies to machine geometry. Our automated supervision runs routine checks and tracks any drift in the production process. Maintenance can step in before quality is affected. That's predictive maintenance. Finally, part positioning and clamping rely on connected tools. They monitor the parameters and automatically correct them in real time.
For our listeners who can't see what we're seeing, every machine has a screen mounted above it. I get the impression that we can see what's happening inside. Is that about right, Julien?
Earlier, we talked about information display. This is it. Operators don't need to walk over the machine. machine. Right from their workstation, they can see its status and what it's doing. We also record the images. That gives us an extra data to review any incident and understand exactly what happened.
And since we're talking about data, the transition is an easy one. If I understand correctly, there's also an issue of digital continuity and real-time data management. Does this data help you in particular avoid breakdowns and manufacturing deviation?
Exactly. We used to work in a corrective mode. A problem occurred, then we investigated it. Collecting the data took time. Interpreting it took time. It wasn't built into the process. Today, we've moved to a preventive approach. We connect the process inputs with the process output. In other words, the dimensions of the finished parts. That lets us control what drives quality instead of simply detecting poor quality. We save a huge amount of time collecting data. And when those links are created across the whole process, that's where the real value comes. We can identify cause and effect relationships we hadn't even anticipated. That gives us much greater control over anything that could lead to poor quality.
Okay, so if I were to summarize what we've just discussed, we're really talking about saving time as well as optimizing the manufacturing processes. Do you have any concrete examples you could give us about those things?
The gain comes in terms of quality. With our data connectivity system and by focusing on the right quality contributors, we've been able, as first step, to divide the number of quality issues by 4. And finally, automated supervisions enables continuous production.
Without being a specialist, I get the impression that you're producing better and faster, which seems like a pretty good equation to me.
It's not about equation, and that's what Industry 4.0 brings. That's why we choose data centralization and systematic data processing as the major transformation lever for this facility.
Now, what about the role of the human operator? We talked a lot about machines and data. What is left in the end for the people who work here every day?
Now, operators can focus on what their job is really about, mastering the process. They no longer spend time on low-value tasks. We've created the right condition for them to do that. The data is available right at the workstation, removing many routine monitoring tasks. Everything is displayed on a large screen on the wall. We know what to do and when to do it. That lets us focus on the key process parameters through dedicated indicators.
And indeed, the screen is right in front of us. We're not going to go through all the figures displayed on it because that would take quite a while and might get a little technical. What we can tell you, though, is that everything appears to be well calculated, well configured, and updated in real time. So it really does provide a reliable and practical view of what's happening.
I'd also add that beyond, let's say, the data that's made available to the operator, you've noticed the atmosphere. We can talk to each other here. We don't necessarily have to lower our voices or raise them. The acoustics of the facility also help the operator stay focused on what really matters. We have made an effort acoustically, both in the infrastructure itself and in the machines surrounding the area. In short, the entire architecture was designed to free the operator from all the drawbacks of a standard working environment.
So speaking of noise, we're going to move to another location now. You're going to take us to our next stop, and our listeners may notice that the noise is going to die down a little bit because we're heading to the control room. Is that right, Julien?
This is a control room that we wanted to make welcoming. We've installed 2 screens here, and this is where we centralize all the workshop data. All the IT networks converge here, and on each screen, we can generate useful reports in real time for problem solving and planning. In short, it ties in with what we were saying earlier. Everything is centered around process control, and all the conditions are in place to make that possible.
Let's come back to the ExcelFAB itself. It has a digital model and a digital twin as well. How do these tools help you in practical terms, especially the maintenance and production teams here in this workshop on a daily basis?
We used the digital twin from the very early stages of the project. In fact, we always used it ahead of the physical project, always looking ahead using the best assumptions available at the time. That allowed us to present the project to investors, to customers, and to the different members of the team, and each time to consolidate a shared vision that was aligned with everyone's requirements. So it consistently allowed us to stay one step ahead. It also allowed us to run through all the major scenarios for the facility. For example, how parts are loaded onto the stations, maintenance scenarios such as how we maintain the machines and the networks, and installation scenarios such as how we bring the machining center into the building. And the most remarkable result was the absence of surprises. Everything happened exactly as planned, just as we had already run it virtually. That was the key contribution of the digital model.
If I understand correctly, you've anticipated every situation, everything that could happen in this building.
Well, we still leave a little room for the unexpected, but it's kept to a minimum.
Another interesting point, Julien, is that the ExcelFAB achieves a 40% reduction in energy consumption compared with an equivalent conventional building. How is it possible to combine industrial performance with energy efficiency?
First of all, we challenged the infrastructure itself. We applied almost office-level insulation standards to an industrial building, which significantly reduced heat loss. We also have a white roof, which limits the impact of weather conditions on the building's thermal performance. That stabilizes everything, and it works perfectly. There's also an intelligent reversible heating and cooling system. We had a centralized thermodynamic, high-performance, state-of-the-art air treatment system that allows us to move away from the older infrastructure we used in the past. And we've also worked on the manufacturing processes themselves. For example, we've made sure the machines are used only to the level that's actually required. In other words, we use the machine's capabilities exactly to the level we need, which reduces the overall energy consumptions of the process by around 10 to 15%.
We're now going to head to the last place you've chosen to show us. Where are we going, and why are we going there?
Let me take you to the showroom. It reflects the spirit of innovation behind Industry 4.0 and another lever we've been able to use. It's a fully digital showroom.
Yes, it's probably worth pointing out to our listeners. We're in a showroom where there are no physical parts. There is a screen.
That's right. And on that screen, on the opening page, we see an aircraft landing. Well, that's perfect, because that's exactly where we're heading, to where our production fits into the aircraft. From there, we can quickly visualize the geometry of the landing gear inside the aircraft and then work our way down to our product, and even all the way down to our machine block. So here, we retrace the entire story from the activity carried out in the facility to the final objective, which is, of course, to get an aircraft flying.
And indeed, this screen, with this part that appears, that you can view in 360 degrees, rotate and examine in detail, is absolutely futuristic. As we've said, the ExcelFAB is a technological showcase for Safran. Is this a model that is intended to be replicated at other group sites?
Our work in innovation has led us to explore the technologies of the future, and we see the benefits of them every day. We see an environment that can evolve, an environment that can grow, an environment whose financial profitability increases with every step, with every new exploration. And what is perhaps even more remarkable is the enthusiasm of the teams to innovate using technology as a lever, enabling us to overcome several limitations that previously existed. It has also helped bring a team together around a shared vision. I'm convinced that many people who follow this example will benefit from it, and so will their teams in many different ways.
And we'll certainly be following that very closely. Thank you, Julien Mille, for being our guide today.
Thank you very much.
And as for us, we'll see you again very soon for a new episode of Radar.